Okay, today's lessons is going to be finding cube roots. A cube root of a number is a number that when multiplied by itself and then multiplied by itself again equals the given number. A perfect cube is a number that can be written as the cube of an integer. We see the symbol is the square root symbol or the radical with an index of 3 to represent cube root. A few things that we talked about was that by calculating the cube root of a number, such as the cube root of 8, we find the number such that when it is cubed, it would equal 8. You could activate the button on your calculator. If you're using the TI-30, it is the second feature above the 0, or if you're using a more complicated calculator, you might have to search for it under the caret. So the cube root of 8 is equal to 2. Because of the fact that an integer can be cubed, we can actually see a negative under a cube root symbol because -2 times -2 times -2 is equal to -8. So that's a little bit different than in our squares and square root. Cubing a number and finding a cube root are inverse operations, and we'll use them to evaluate expressions and solve equations. In the first example, and this is in your textbook, finding each cube root, so we already talked about the cube root of 8 being 2. Example B, part B, cube root of -27 tells us that we want -3. And for C, when you are dealing with the cube root of something that's in a fraction form, you could evaluate the cube root of the numerator over the cube root of the denominator. So cube root of 1 is 1, the cube root of 64 is 4, and that's how we get 1/4. So to give these a try, what number times itself and then times itself again would be equal to 1? The answer is 1. Using your calculator to help you solve number 2, we know that when there's a negative under the cube root symbol, we know that value will be negative, and in this case it is -7. Again, if you're using the TI-30 calculator, you would put the value 343 in your calculator, hit the second key, and then hit the 0, and that literally will give you the -7. For 3, the value will be negative, and we are taking the cube root of 27 and all that over the cube root of 1,000, so we get a -3/10. To evaluate expressions, you use order of operations, and you would evaluate cube roots at the same time you would evaluate squares and square roots. So for part A, you're taking 2 times the cube root of -216 minus 3. You can see that if you evaluate the cube root, that's -7. So the cube root of -216 is -6. When you multiply 2 times -6, you get -12. Subtract 3 and you get -15. This next one kind of highlights taking the cube root of a number and then cubing it. So when you take the cube root of a 125 and then cube that value, you're right back to 125. So 125 plus 21 equals 146. To evaluate these expressions, we have 18 minus 4 times the cube root of 8. The cube root of 8 is 2. So you know that you have to multiply before you subtract. We would do 18 and multiply 4 times 2 to get 8, and finally subtract to get 10. Taking the cube root of a -64 and then cubing that value, it's like taking -4 and cubing it. Okay, this is kind of an unnecessary step because we know the value will be -64. When you take -64 plus 43, you get a -21. In this next one, 5 times the value of the cube root of 512, which is 8, minus 19. You multiply first and then subtract, and your answer would be 21. In this next example, you are going to be substituting in a value for x. and doing the order of operations as before. So in this case, you'll put the 192 in place of x, which is in the numerator of each of the fractions, and then you simplify. So 48 plus the cube root of 64 would be 48 plus 4, or 52. So substituting in values, we are told that y is equal to 64. So the cube root of 8 times 64 plus 64. Two ways to solve this. Because 8 and 64 are each individually perfect cubes, we could take the cube root of 8, which is 2, and the cube root of 64, which is 4, and multiply those. Or you can simply multiply the two numbers, keeping them under the cube root symbol, and then evaluate that. So we get the cube root of 512, which is 8. When we add 64, the final value is 72. Everywhere you see a b, you will be substituting in a -3. So 2 times -3 minus the cube root of 9 times -3. So if I take 2 times -3, I will get -6 minus, and in this case, the cube root of -27. So -6 minus a -3, evaluating the double negative here to be adding, so -6 plus 3 is -3. In our final example, we're going to be finding the surface area starting with the volume of a cube. So we'll use that information to find the side length. By taking the cube root of the volume, we'll get a side length of 5. Substituting the 5 into the formula for surface area, which would be 6 times the area of one face, or that side length squared, you can calculate surface area. So let's give it a try. The volume of a music box is shaped like a cube and is 512 cubic centimeters. Find the surface area of the music box. So again, relating the two formulas, volume is side length cubed. Surface area is 6 times the area of one face, because there are 6 identical faces. So since we know 512 is going to be equal to that side length cubed, taking the cube root of 512 is the inverse operation of cubing a number. So the cube root of 512 is 8. The cube root of s cubed is s. And again, this dimension is in centimeters. If we're using that to calculate the surface area, we'll take 6 times the area of one face, which is 8 squared. 6 times 64 is 384 centimeters squared.